On the moon, the acceleration due to gravity is about -5 feet per second squared. An astronaut jumps into the air with an initial upward velocity of 12 feet per second. A, how long is the astronaut off the ground? So we're given acceleration. If we want to know how long the astronaut is off the ground, we're going to have to solve for the distance equation or the height equation. So from acceleration, I do the antiderivative to give me velocity. So the antiderivative of -5 is -5t plus the initial value. Usually I'd put plus c, but in this case, if you put plus c and then plug in 0 for t and 12 for velocity, you end up with c equals 12. That will not work for anything except for a polynomial, so make sure if you have an exponential equation or a trig function, you actually solve for c the old-fashioned way. Okay, and then the antiderivative of velocity gives me the height equation, so -5 over 2t squared plus 12t, plus the initial height is 0, because we're going to assume he is on the ground, or on the moon, then he jumps in the air and then lands again. So in order to figure out how long he's off the ground, we need to solve for when the height is equal to 0, because if you're on the ground, the height is equal to 0. You can just factor out a t on this one, and you end up with t times -5 over 2t plus 12. So you can plug in t equals 0 and get 0, but that's just the initial time when the height was 0, which is when he begins the jump. But to figure out when he ends the jump, you set the other part equal to 0. Go ahead and solve for t here, and you end up with t equals 24 over 5 seconds. For part B, how far off the ground does the astronaut rise? If I want to figure out when he's at his maximum height, I want to figure out when the velocity changes from positive to negative. So I'm going to start with the velocity equation, because when the velocity changes from positive to negative, that's when the astronaut is at its maximum height. So I'm going to find the critical point of velocity by setting 0 equal to -5t plus 12. I'm sorry, not the critical point of velocity, the critical point of height, which is the 0 of velocity. And then I solve, and I get t equals 12 over 5. Now that's just the time when the astronaut changed directions from positive to a negative velocity. So what I need to do is plug this time into the height equation to figure out what was the height at 12 over 5. So I plug in 12 over 5 into my height equation, and I simplify. 12 squared is 144 over 25. And then I just simplified as I went. So I got -72 over 5, and then 12 times 12 is 144 over 5. 144 minus 72 is 72 over 5, and this is in feet.